Good afternoon. My name is Wayne Beaton. I'm with the Eclipse Foundation. I'm going to talk today about Eclipse. The title of the talk is an ALM, an Application Lifecycle Management success story. We're having a little bit of, we're just a few minutes away from being ready to actually start the talk, but there's a couple of things I'd like to discuss before we begin anyway. Of all of you in the room, how many people are using Eclipse today? Excellent. All right. Is anybody, I'm assuming that most of you, maybe a show of hands again, how many people are just building regular old Java applications using Eclipse? Is anybody building Eclipse components into their application, shipping with something like Eclipse Link or Equinox, that sort of thing? Okay. Using Eclipse for C and C++ development? A couple? All right, interesting. Not there yet. I'm assuming that at least a few people in the room are here because this is the only talk that has Eclipse in the title. Oh, okay, not for me. So probably a few of you are interested to know about what's new and interesting in Eclipse. With Eclipse, in June this year, we released Eclipse Juno, our Juno Simultaneous release. The Simultaneous release brings together, I'm actually going to talk a little bit about this in my talk, brings together all of the Eclipse components and okay. I'll talk about that as we go on then. Okay, good afternoon, we're on. So again, my name is Wayne Beaton, I'm with the Eclipse Foundation. My official title is Director of Open Source Projects, which means I don't get to write software anymore. Although I do sneak it occasionally on the side when no one's looking. Definition of application lifecycle management as I'm going to discuss it. Continuous process of managing the life of an application through governance, development, and maintenance. I liberated this from the Wikipedia. This, in my mind, is a reasonable definition of application lifecycle management, and I believe it's an industry-accepted definition as well. What's key in this definition is that it is more than just a bunch of tools. There's concepts of governance, maintenance. People are involved with application lifecycle management. The title of the talk, or I guess the subtitle is, let me just back up a little bit, How I Learned to Stop Worrying and Love the Build. The question is, why was I worrying? At Eclipse, we actually have more than 250 different open source projects. Many of them are focused on things that you would recognize from the IDEs, various IDE products that you use based on Eclipse technology. Some of them are different. We have, for example, the Higgins project does identity management. That's pretty cool stuff. The whole identity management community is actually pretty different from the Java community. There's some crossover, but within the identity community, Higgins is huge. We have Tycho, which is build technology for building OSGI bundles. We have Eclipse Link, which is actually part of Glassfish. That is object relational persistence mapping. We have lots of different projects, and each of these different projects it does things a little bit differently, and we like that. We think that's a good idea, that projects get a certain amount of latitude to do things the way that they think they should be done. However, this has resulted in people doing things a lot of things differently, including builds. We have lots of different build technologies out there, and traditionally they're projects that just needed to get something done, built some scripts on Ant, based on Ant, and we have some Maven, and there's some Ivy in there, and there's a whole bunch of different kinds of things, and orchestration was done differently by a lot of different projects, and this resulted in builds that were difficult to repeat. I don't know, has anyone actually ever tried to build Eclipse? Okay, and you still have your sanity apparently. Most more or less intact. You may actually be interested to know that we've undertaken an effort to migrate the entire Eclipse build process to Maven. And we've actually heard reports of people pulling in the entire Eclipse source tree and then building in about 16 minutes. Right? If anyone's ever tried to do an Eclipse build based on PDE build, again, if you don't have a crazy look in your eyes, I don't believe you. So over time, we've made some changes in how builds are done at Eclipse. A lot of older Eclipse projects use something called PDE build. PDE is the plugin development environment. This is what developers use to build plugins for Eclipse. PDE build was some technology that actually heavily leverages Ant by generating Ant scripts and then running Ant scripts, and it's been described as black magic. It's one of those things that works great as long as it works, and when it breaks, then you wind up getting old and gray. Combination of PDE build using cron and CVS, that's kind of how we started. Over the years, I think 2006, 2007, we added in SVN support. We then started an effort to build what we called a common build infrastructure that we were calling Athena, which tried to make PDE build more palatable. We introduced Hudson. Around about the 2009 mark, we introduced Git. Git is spreading like wildfire amongst Eclipse projects. In fact, most of our projects now are running on Git repositories. And we've deprecated the use of CVS. December 21st of 2012, all Eclipse projects will no longer be using CVS. Around the 2010 time frame, we started introducing Maven and Tycho as build technologies. Gerrit then came along, and now we're actually at a point where we're starting to see some projects using continuous integration as part of their Gerrit solution, which I'll talk about in a minute. So the question we continually ask ourselves is, are we there yet? And the answer is no. We're really never going to be there. There is no there. There is no one single perfect solution for build. We see this as an evolving thing. As new technologies come out, we explore them. It took us a little while to embrace Git. It took us a little while to embrace Maven. But over time, the community is what actually decides. This is actually something that a lot of people don't understand, is the Eclipse Foundation itself doesn't really hold a lot of power. The community is what holds the power, and we look to the community to tell us what we need to be doing. And unfortunately, to do that requires a certain amount of consensus within the community, which is oftentimes difficult to get. So with Git, and certainly with Git and Maven and now Gerrit, we've gotten a lot of consensus in the community that these are good technologies that we need to be pursuing. And we've embraced them, and a lot of Eclipse projects are moving forward with them. Just a little bit of background, some project metrics. We have a little more than 1,000 committers. That's been true for about the last year and a half or so. That number does fluctuate as new projects are brought on. Sometimes we terminate projects that are no longer viable. Projects bring on committers all the time. Actually, is anybody in the room an Eclipse committer? Oh, that's interesting. Okay, not one. Okay, one. So the idea is that people contribute to various Eclipse projects, and over time, by demonstrating that they understand what they're doing, and they understand the developers gain confidence that they will do no harm, contributors will get invited to be committers. So that's a number that increases at a fairly regular rate. And then decreases occasionally as well, because, like I said, sometimes committers become inactive for different reasons, and sometimes projects just disappear. Last time I checked, we had 104 different companies with committers represented. So 104 different companies had active committers actively contributing to projects, which is pretty cool. 255 different projects. Spanning lots of different things. We actually have a whole section of projects now that are dedicated to doing runtimes. Gemini project does OSGI integrations with different Java EE technologies. I did mention Eclipse Link earlier. We have Virgo, which is the Spring DM technology brought into Eclipse. We have 522 Git repositories. So some of these projects have more than one Git repository, depending on how they choose to do things. I know Virgo, for example, has I think about 10 or 12 different repositories for different functional areas. The Eclipse project has probably about that many as well for each of the different functional areas. We have 29 different Subversion repositories, and some number of projects still using CVS, which we refer to as the dead projects walking. Basically, on December 21st, we made a decision about 2 years ago that we had to get rid of CVS. There's a couple of problems with CVS. First off, the technology is, well, frankly, its time has come and gone. There's actually a couple of bugs in CVS that aren't being fixed, which is a concern to us. The community is kind of leaving CVS, which I don't know, it seemed like it was good for the times, but it's time to move on. Anyway, December 21st is the magic date where we're shutting down CVS. Coincidentally, Kepler version M4, which I'll talk about a little bit later, that's our next version of our simultaneous release. The milestone 4 build is on that same day. And of course, the end of the world, according to the Mayan calendar. We picked the date on purpose. We thought it would be funny. The simultaneous release is something, again, that we've every year, some subset of these 255 projects release together. They release on the same day, but there's actually some coordination that occurs as part of that, and I'll talk about that a little bit more. But you'll see that we have a curve that's growing in terms of the number of projects that are participating and the number of lines of code that are in here. The red line is the number of lines of code, millions of lines of code that wind up in this release. So we released on June 26th of 2012 the Juno release with 71 projects and approximately 60 million lines of code. So going back to application lifecycle management, the recipe for success is this sort of three aspects. We have the process, people, and tools. She's probably looking for action shots. Oh, well, what can you do? So I'll talk a little bit about our development process. We have the Eclipse development process, which all Eclipse projects and all Eclipse committers agree to make use of. And this is actually a collection of rules and processes that exist that are oftentimes described as heavyweight and painful. But really what they do, they exist to help Eclipse projects operate in a true open source manner, in the way that we describe them, or the way that our community has decided is important. All Eclipse projects are required to operate by our rules of engagement, which require being transparent. That means basically decisions that are made have to be made in a transparent way. They need to be made in Bugzilla or in a mailing list or somewhere that people can actually find them and see them. But it's more important than just being transparent, more important than just telling people what you've decided. Eclipse projects are required to be open. They need to be they need to be open to all players. Anybody who wants to come and participate with an Eclipse project is able to, on a level playing field. Now, that's not to say that if you write a bug and say, I demand that Eclipse have such and such a functionality, that's not really enough. But if you come to us and say, hey, I think there's some new functionality that we can add to an Eclipse, and I've got a couple of developers and I that want to work on this functionality, and we think that this is going to be good stuff, you have to be heard by the project. The projects have to give you a chance. And sometimes it means maybe making a new project. Sometimes there's an existing project where that new functionality may work. But if you come to us wanting to do some work on Eclipse, we have to take it. We have to at least work with you to try and bring it in as best we can. Or in some cases, very often a project will say, we're not going to accept this functionality because it's not within scope of our project. In that case, I'll help figure out where a good place to put that functionality is. Meritocracy is our third rule of engagement. Basically, you earn your privileges too. So if a contributor over time will earn the privilege of being invited to become a committer on the project and then get the ability to actually write into our source repositories and produce software that millions of people around the world will eventually use. I actually have a student working for me right now, and he's contributing just little tiny patches here and there. And the development teams are all being really, really receptive to the work that he's doing because it's quality work. He's doing a good job. And over time, he will very likely be invited to be a committer, although he's a little bit young, so there's other areas, not related necessarily to the code that he's producing, where he needs to develop some maturity. We also have the 4 C's, which this is sort of not documented exactly like this in our process, but Eclipse projects, at Eclipse code speaks. We actually don't accept new projects at Eclipse unless they have code already. It's not enough to come to Eclipse and say you want to do wonderful things. You need to show us that you're doing wonderful things before you can even become an Eclipse project. And then throughout the life cycle of a project, having code is important. A project needs to actually continually produce code to be viable at Eclipse. The community is also important. Eclipse developers, it's not enough to just be a whiz-bang developer and lock yourself in your basement and write code. You really need to interact. Our community is full of different types of people. We have we generally categorize them as 3 different types of communities. We have the end users. These are just people who use Eclipse to get their job done. We have adopters. These are people who take Eclipse and use it and integrate it in their products, and we have a whole ecosystem built around people that do that. And then we have developers. These are the people who actually contribute to Eclipse projects. They write code. They're the people, in many ways, the rock stars that produce the stuff that everybody loves. For an Eclipse project, these are all important. These all have to be important, and these communities all have to be actively courted. When the initial Eclipse work was being done, the Eclipse developers were spending, depending on who you talk to, the numbers they vary a little bit, but anywhere between 30 and 40% of the developer's time, every developer's time, was spent interacting with the community. And that was going out to events, talking at Java users groups, going to customer briefings, that kind of thing, and getting Eclipse in front of people and talking to them about it and answering questions and making people aware of the work that they're doing. And we've found that our most successful most successful projects are the ones that do this and make this an active part of their developers' time. Some projects actually have full-time evangelism resources. The BERT project, for example, actually employs at least 1 or 2. Their main sponsor, Actuate, employs 1 or 2 people whose job it is to make sure that people are being successful with open source BERT. Anyone heard of BERT? The Business Intelligence Reporting Tools. It's basically reporting tools working in Eclipse. It's a great example, actually, of a project that's not really intended for software developers. Software developers can use it, of course, but it's really meant for business analysts primarily to build reports and charts and all that kind of wonderful stuff. Cleanliness is another important aspect of being an Eclipse project. Where does the code come from is a big challenge, actually, and this is something that if you're doing open source work, these are questions that you really need to have answers to. We actually have a team at the Eclipse Foundation that takes care of making sure that code is clean from an intellectual property point of view. So questions like who owns the copyright of the code, sometimes the answer to these questions is not entirely obvious, but we need to make sure that all of the code that comes into Eclipse is actually authored by the people who say they authored it, that they have permission to actually contribute it, and that they are contributing it under a license that's friendly to the project license. Generally, projects are licensed under the Eclipse public license. Quality is, of course, misspelled because of quality control concerns, quality at Eclipse comes in lots of different ways. Transparent issue tracking is one thing. All Eclipse projects are required to do all of their bug tracking in our public Bugzilla instance, where everybody can see it, everybody can collaborate, everybody can contribute. All discussions are meant to be public. Some projects are staffed by people who all work for the same company. Sometimes these people all work next to each other. When they have their when they have their hallway conversations, their conversations around the water bottle or whatever about their project, the most successful projects do this, and all projects are required to actually capture those conversations. Here's a discussion that we had, here's what we decided, and then open that discussion up to the community for for more open participation. Inviting and accepting participation is another big part of quality. By allowing other people to look at your code and participate in your design decisions, and then the fact that it's out there for anybody to see has a big impact on quality. Diversity is also important. We look for projects to diversify beyond a single company sponsor. Some projects are more successful at it than others. Our eGit project, which provides Git integration, for example, has, I think, on the order of about 8 to 10 different companies represented in their committer role. The simultaneous release is another big part of quality. By getting these projects, getting multiple projects to release together. We force them to coordinate, or this process forces them to coordinate their schedules and forces them to communicate with each other. I say forces, it's not like it's a hard thing to do. They want to do this. This makes it easier for them to collaborate and work together. And of course, with we have some new effort underway with the common build infrastructure to make builds a lot easier and more consistent, which again will contribute to overall quality. Intellectual property management is a big deal at Eclipse. Like I said, we have a whole team dedicated to managing intellectual property. Intellectual property management is really about risk mitigation. We want to avoid a situation where somebody's code inadvertently winds up in Eclipse. Maybe a software developer contributes something that belonged to somebody else, and we have to make sure that the permission chain has been properly asserted, properly documented and captured. We start from an assumption that open source projects want to be successful. If you want to be successful, then you want to have adoption, or adoption is certainly a key metric, I think, of success. If you do care about adoption, you want people using your software, you have to care about intellectual property management. You have to care about whether the code that you're shipping in your product is actually code that you can legally ship, and that everybody agrees that the code that you're shipping is clean. I'm just going to move through this. So again, just review. This will be the last slide about intellectual property. We have a team that takes care of this. They want to find out who owns the copyright. Is the owner really the owner? Very often the author of some code is actually not the owner of the code. And we actually have lots of organizations that want to contribute, but their management won't let them. Generally, the company that you work for, in many cases, the company you work for is the one who actually owns the code that you're contributing. What license does the owner grant? Are they compatible? You might be surprised. For example, the GPL and the EPL are fundamentally conflicting. You technically, strictly speaking, cannot ship a product that includes some GPL and some EPL code. But and we certainly at Eclipse, none of our projects distribute any GPL code because we just can't. So anyway, I guess the question is, do you care about adoption? If you don't care about adoption, then you probably don't care too much about intellectual property management. Or quality, I suppose. Anyway, so I'll talk a little bit about some of the tools that we use at Eclipse. The tool stack is really a bit of a graph. I put Eclipse at the middle of this graph. We use Hudson. Hudson is actually an Eclipse project now. Oracle brought it over to Eclipse, and they have a team actively working on Hudson. I'm sure that many of you have heard of Jenkins. There's a Hudson-Jenkins split. Jenkins has gone off in their own direction. In fact, they have a very different intellectual property policy than we do. They have a policy of if somebody notices something bad, we'll go back and we'll fix it probably. Where we tend to be more proactive. It actually took us about a year to review all of the intellectual property for Hudson and get us to a point where our IP team was comfortable with the content of Hudson, that it could be legally distributed under the EPL and consumed by our many adopters and consumers. But anyway, so Hudson at the top of this stack for build orchestration. Most of our projects, like I said, are now using Git. Some are still using CVS, and some are using Subversion. Some of those projects using Git are actually using Gerrit. Gerrit is a code review feature. It actually has a really neat workflow where anybody can actually push code into a Gerrit repository. From there, the people involved in the project get to vote. And if it gets enough votes and the committers accept the patch, it can be pushed into the project's proper Git repository or pushed to the master branch anyway. Hudson can be configured to have a vote so that when code gets pushed, when someone pushes into a Gerrit repo, Hudson wakes up and goes, oh, all right, and it goes and grabs that patch or that push, pulls in all the code, builds everything, and then reports back to Gerrit whether everything built properly or not, if there was errors. So Hudson winds up getting a vote on our code review. We have a couple of projects doing that now. That's pretty cool stuff. Of course, we've as I said earlier, we've started a migration over to Maven-based builds, and we have some tooling within Eclipse. The M2 Eclipse project produces some Maven script tools, Maven scripting tools, Maven integration tools. We have integration from Eclipse to Bugzilla. We have integration from Eclipse into Gerrit and Git. And down at the bottom, I have IPzilla, which is actually a customized version or instance of Bugzilla that we use for intellectual property tracking. So we have this massive collection of technology that's all doing wonderful things, all interacting very nicely together directly from within Eclipse. So it's actually possible to use all of this technology without ever leaving the comfort of your Eclipse IDE. And in fact, I believe the Eclipse IDE for Java developers today is shipping the eGit integration and the Maven integration. Of course, the Bugzilla integration, I think, is with that as well. The Hudson stuff, you would have to, Hudson integration, I believe, is separate download from the Mylyn project. So there's a handful of Eclipse projects. I just did mention Mylyn briefly. Mylyn is the, does anyone actually use Mylyn? Mylyn does some wonderful task management stuff. If you're not using Mylyn, you should take a look at it. It will change your life. The Mylyn project provides all those various integrations. The eGit project is doing some wonderful things with Git integration from within the Eclipse IDEs. M2 Eclipse with the Maven integration. Hudson, of course, with build orchestration. And Tycho is another project which I mentioned a little bit earlier. That project is Maven plugins that are good for building OSGI bundles and Eclipse-specific artifacts like distribution repositories. We love Git, and this is a new function that we're working on. All of our project pages will soon have a section that looks like this to make it a lot easier for people to get access to our Git repositories. So in this case, we see this is the Tycho project. Has 4 repositories. You can see that 3 of them are actually replicated on GitHub. Eclipse repositories are replicated on GitHub. Some Eclipse projects have been accepting pull requests directly on GitHub. We have a workflow that allows us to do that now. Some of these repositories actually have Gerrit integration as well. Of course, you can just copy and paste URLs and get access to our to Eclipse project code very quickly if you wanted to contribute or if you just needed to modify something within the Eclipse code base. I did talk about Gerrit already. I got excited and got to it before my slide. The continuous integration and build maturity is a problem that a lot of projects have to face. The Eclipse project has a fairly, like I said earlier, we've actually started a process of migrating the Eclipse project to Maven, but it's still a single build. The Eclipse project is a big thing that has lots of different parts, and over time we are going to be refactoring it to the point where it will be far more modular and sections of it can be built. These projects that are more modular, let me think, Tycho I think is one. There's a handful of projects that are able to use continuous integration because they can do relatively small builds. The bigger projects are just too heavyweight right now, and just the impact on our build technology, our build farm is too big. Our Hudson is configured with a number of build slaves. We have slaves for performance testing, UI testing for Windows and the Mac, and it's actually there's a Linux box in there too for Linux-based testing. But we have a fairly complex Hudson instance, which unfortunately we have to restart every couple of days because, anyway, I'm not sure exactly why. Our webmaster takes care of it. He does a brilliant job. Hudson Metrics, we have about 340 jobs. 100 of them or so run every day. 220 of them run about every month. We've so far, since we installed Hudson, I can't remember, what was the date, 2009, 2010, we run about 100,000 builds on this infrastructure, which is about 260 jobs, runs for each build job on average. So we make pretty heavy use of Hudson. Some of our projects are building, like I said, continuously. Some of them build nightly. Many build weekly. So, we have different types of builds, integration, and nightly builds, integration builds, and anyway, different types of builds. We also provide we have a special repository of IP clean third-party artifacts. A lot of projects use things from Apache, for example, or other libraries. We make those available in a repository that we call Orbit. These clean third-party artifacts are also bundleized, which means that you can use them from an Eclipse project or an OSGI-based infrastructure. If you were, say, using a lot of application servers today actually have an OSGI base, so there's some potential to use a third-party IP clean third-party libraries there, for example. We actually have a lot of people using the OSGI base, what we call Equinox, our Equinox project, as the basis for different types of runtime, both just headless applications and server-based applications, some running on relatively small devices as well. We have a lot of projects, a lot of tools for the different projects. At Eclipse, we maintain, like I said, intellectual property management information. We have a tool that helps projects create an IP log. This IP log keeps track of the different third-party libraries that an Eclipse project uses. It also keeps track of contributions. If you provide a contribution to an Eclipse project, that's your property. Or your company's property, whoever you're writing software on behalf of owns that. So we keep track of that in an IP log, and we actually can do this in a fairly automated way with Git repositories. The author information that's captured in a Git commit is a handy way of getting that. We also have a way of if you've submitted a patch via Bugzilla, we can keep track of that. That's actually something that's different about Eclipse than, say, OpenJDK. If you contribute something to Eclipse, you own it. We don't take ownership of it. You license it to us so that we can use it in our projects. We have a tool that scans our downloads to make sure that the things that a project is providing as part of their distribution have all been run through our intellectual property process. We use this to identify different libraries and uses. In fact, you see like Activation 1.1 is being used by this particular project by Hudson, and they have a CQ, which is a contribution questionnaire. Basically, we registered this project has gone through the process of making sure that the intellectual property in this jar is clean. We have a tool that scans our Bugzilla for intellectual property or potential intellectual property contributions that should be recorded. So this is something that projects can use to make sure that they didn't miss something, find something that should be in their intellectual property log. A lot of companies that adopt Eclipse technology care about these intellectual property logs, so we maintain them on their behalf. We also have a page that committers can access that gives us an overview of the different contribution questionnaires. This is essentially a library of all of the different third-party code and major contributions to Eclipse that can be reviewed. And again, projects can use this to identify third-party libraries that they may want to leverage. So tracking IP, again, we have that IP log. It pulls information in from Git, Bugzilla, our IPzilla, which is a custom Bugzilla instance that keeps track of third-party libraries, runs them through its IP log generator, and spits out a log that projects provide with each release that they make of the Eclipse software. The Eclipse people, there's lots of different people involved. I've talked a lot about committers. Committers are the people doing the actual work. Projects all have project leaders, one or more project leads. Project leads are responsible for doing project management sorts of activities, helping the committers do what they need to do. Projects also fall under a PMC, a project management committee. The project management committee provides oversight, guidance, and management to the projects. In the case of the Eclipse PMC is the one that sets the plan for each release. So for the upcoming Kepler release, which will be in June of 2013, it's the Eclipse Project Management Committee that will be deciding what functionality should be in that and what will not be, what the development priorities are going to be. We have an architecture council. This is a group of people who have been part of the community for a long time. They understand our processes, and they are made available to new projects that come to Eclipse to help them understand what they need to do. The Planning Council is a little bit bigger, a little bit higher level than the Project Management Committee. We have multiple Project Management Committees, which each have responsibility for a functional or logical area within our Eclipse project space. The Planning Council is above all that, and their job is to collect the input of all of the various PMCs and set a broader plan for how we're going to be doing things at Eclipse. More pragmatically, they're the ones that decide what goes into each release that we make every year. In this case, this year, the Kepler release. Intellectual property team. Right now, we have a staff of 3 people. Their full-time job is to make sure that the intellectual property in Eclipse is clean. We have me, the director of open source projects. I basically make sure projects are understanding help projects understand why we have the rules that we do and why they're valuable and then help them work towards being more effective open source projects. The executive director is the head boss. He's the guy who signs my paycheck, so I thought I should put him down on the slide. So we've got this notion called a common build infrastructure. This is something that's been changing over years. As new technologies become available, we change what we call our common build infrastructure. The idea here is that we have some common infrastructure bits like Hudson that are available for projects to use. We have some common technologies like Maven and Tycho and Git and other things that projects can use, and we provide services around them. And we actually have a full-time staff member now at the Eclipse Foundation whose job it is to help Eclipse projects do builds. The idea is we want to be able to make it so that anybody can get just about pick any Eclipse project they want and have a fighting chance of being able to build it themselves. Which, as I said earlier, has actually been a challenge traditionally. This is opt-in. Projects still have flexibility and freedom to do what they think is best to serve their community and their developers. But what we've done is we've made the common build infrastructure very palatable. We make it so that it's just dead easy to use it, and we're finding projects are swarming to it. Again, our main goal is to encourage participation and increase the awesomeness of actually trying to contribute to Eclipse projects and to enable long-term support. We've actually started a new effort to provide long-term support at Eclipse because we've been working with a few organizations who have determined that based on the life cycles of the projects, the products that they are creating, some of them, the most extreme I've heard is a company that's putting a product into service for 70 years. Anyway, they rely on a number of tools to make sure that their product is still sustainable and supportable for a very, very long time. And they've determined that open source is the only way to do that. And making it so that we can have Eclipse technologies be part of that solution and make it so that 25 years from now, someone will still have a fighting chance of being able to build Eclipse and build the output of 5 or 10 different projects is a really big deal. Anyway, I found that whole discussion fascinating. Talking, in my professional career, I've worked with organizations that are putting systems into place for 5, 6, 10 years. It's eye-opening to talk to someone putting something into service for 70. I'll let you use your imagination to figure out what kind of product that is. But the idea is, proprietary companies providing closed source solutions go out of business. They get sold. They get moved around. In many cases, open source is the only way that you can possibly support a tool chain for an extended period of time. So again, with common build infrastructure, we're trying to make it easy to build, easy to get started, easy to get community to work. We're trying to decrease the pain and increase the awesome. This is an ongoing process. We think with Maven, Tycho, Git, Hudson, we think that we're at a point where it's pretty straightforward, pretty easy to do builds now. I actually set up for a project I was working on, I set up a Maven and Tycho-based build for it in about 3 minutes. It's crazy simple for simple, relatively small projects. Turns out it's actually fairly painful and hard for very long and long-established projects like the Eclipse IDE stuff, but that's something that we're working on as well. So basically, we are looking at this sort of thing. Projects have a Git repository, use Hudson, Maven, Tycho to build, maybe pulling in some artifacts from Orbit, and pushing out a repository of consumable artifacts for the community. One of the things we don't have yet, and we're working on, is actually having a Nexus instance at Eclipse, so that we have maven.eclipse.org, where you can go and get Eclipse artifacts directly, and of course we'll push that to Maven Central. Again, make all that. A lot of projects do that today anyway, but we're working on a process of making all of that happen automatically for Eclipse projects. Okay, so I'll talk a little bit about our simultaneous release. The simultaneous release, as I've mentioned already, is the combined release, a coordinated release of multiple Eclipse projects. What most of us think about as an Eclipse, you probably go and download the Eclipse IDE for Java developers. That includes code from the Eclipse project, eGit project, there's some from the Web Tools project, the XML editing stuff is from there. There's some EMF, Eclipse Modeling Framework code in there. It's a combination of code from various projects. The Eclipse Classic is, if you download Eclipse Classic, that is just the output of the Eclipse project itself. Anything you have that has extended functionality, the Eclipse IDE for C and C++ developers, for example, has bits and pieces from other projects. A lot of this work was done to help spur commercial adoption, and we were told by a lot of commercial adopters that having all of these different projects on different release schedules was just too hard. So they asked us to work on this, and projects have opted in. Like I said, with Juno, our latest release, we had 71 projects opt in to participate. Before we had the simultaneous release, we had something along these lines. This is actually, like I say at the bottom, hypothetical and ridiculously simplified. The problem was really hard, actually. Equinox and the Eclipse platform is always shipped in June, but then maybe EMF is in September, but Rihanna requires EMF, so it ships sometime later in January, and GEF is in April, and some other product. So by the time you have a completely up-to-date stack, you're ready for the next release of the Eclipse platform. And that was just too painful for too many people. I'm certain anybody who's been in the Eclipse community for more than about maybe 7 or 8 years will remember the pain of what it was like to try and assemble a whole bunch of plugins from all over the place and see if you could actually get all the versions right and make it work. So with the simultaneous release, we've again tackled the transparency problem and make it transparent so people know what's going on, predictable. It's part of that. We allow our ecosystem to actually start doing their own integrations in a very predictable and scheduled way. And of course, this helps the whole community. When you get Eclipse in June of 2013, you'll be able to add all the functionality that you need to it right away without having to wait for other projects to catch up. This is not a project unification. All the projects that participate in the simultaneous release are actually still separate. They have their own project leadership, their own committers, they have their own project plan, they have their own repositories, they do their own builds. We make them coordinate, we help them coordinate their plans and schedules with each other so that they can release together. So pragmatically, the simultaneous release is about coordination and collaboration. We set up a bunch of dates in advance. I've listed them here on the slide on the right. Milestone 1 actually occurred a full 2 weeks, I think, after the last full release. So we released Juno in June, at the end of June, and then, it's about 4 weeks. Anyway. Some number of weeks later, we were already producing the first milestone of Kepler. And what Kepler is it's all the Eclipse projects that are participating in the release train are contributing their bits. And on milestone 1, they all come together and they have all their builds complete, and we pull it all together and make sure it all works together. And then this gives the community and the developers an opportunity to look at the code. And we have each of these milestones as we progress through. One of the previous speakers before lunch was talking about dog fooding. Like, this is extreme dog fooding. We're more than just testing the stuff that we're producing. We actively use the stuff that we're producing. The Eclipse project actually uses some of them actually do it daily. They use the build from the previous night for their work during the next day, but never more than about a week. Most of the Eclipse team developers actually pull the bits that they produced the previous week to use to build the bits for this week. Right? So Eclipse is used to build Eclipse, and with the release train, this is done to the extreme. We produce about every 4 or 6 weeks, we produce a new combined build of everything that's going to be in the simultaneous release and make it available to the developers to use and to the community to test and provide feedback. This is again part of the quality discussion that we had earlier. To make this coordination actually work, I've got another table here. We have this notion of offsets. Different projects sign up to on a particular offset. The Eclipse project is kind of the root of all evil at Eclipse, so it's a +0. But a week later, or actually, depending on the release, it could be a couple of days later, EMF, Eclipse Link, and GEF, for example, will release, and then after that, BERT and a bunch of projects. So they decide at what point do they have to do they release. So we set a date. That's +0, and then 2 days later is +1, and 2 days after that is +2. So the projects actually stagger how they release their bits so that they can do some testing on the stuff that comes before them before they put it into the master build, which runs at the end of +3. At the end of +3, we have a massive build of everything that goes into Eclipse. All along the way, projects are communicating, testing, finding issues, and resolving issues. So our simultaneous release, in a nutshell, looks a little bit like this. I've got on the left side, I've got project repositories. Each project has their own Git repository, and as I said earlier, sometimes this is CVS, sometimes this is Subversion, pardon me. Projects have their own build, which produce their own bits. In OSGI terminology, they're bundles. They generally look like jar files, if you're not sure what OSGI is. They produce their own artifacts into their own artifact repository. Now, you could go to those artifact repositories and install these bits directly into your Eclipse installation if you chose. What we then do is the aggregator, the simultaneous release build aggregator, pulls all of these bits out of all of these different repositories and generates a composite artifact repository, which the packager then picks up and uses to produce all of the Java, the various Eclipse packages that you've come to know and love. I've listed a few of them at the bottom. We actually have, I think, about a dozen different Eclipse packages that we produce of different types. Often we actually get questions from people, how come you don't produce a package that includes everything? Well, if that would be a huge thing that nobody really wants. Nobody really wants everything. All of these packages are connected to this composite artifact repository, and every single package we could produce, you could actually use the install new software option to pull the bits from other functionality, other projects produce, and other functionality into your Eclipse IDE. Or you could use the Eclipse Marketplace to pull in other functionality as well. So each of these packages that we produce, these IDEs that we produce, is itself something that can be modified and grown as your requirements dictate. With that, actually, I'm done the content of my presentation. The idea is basically, though, that at Eclipse, our application lifecycle management story, is built on a lot of different technology. But there's a lot of people involved, there's a lot of process involved, and all of this together is combined to make what I think is arguably a very successful story in terms of every year the Eclipse community of developers is able to deliver what they say they're going to deliver on time with good quality. Are there any questions? Nothing? I've lulled you into silence. All right. Well, with that, I give you back, I think, 9 minutes of your time, if this clock in front of me is accurate. And I appreciate your patience and your attention, and I hope you... Oh, is there a question? Sorry, you're caught in the light.
No problem. You were talking about dog feeding?
Yes.
And you're building Eclipse with your own previous build Eclipse?
Mm-hmm.
So I assume it can be a problem that your current build
So the question was about dog fooding. I commented on dog fooding earlier, and I had commented that the Eclipse teams in particular, the teams that are producing the IDE that you're familiar with, in particular, actually uses the build from either the previous night or the previous week to build the next thing. And the question are sometimes things missing from that, I believe. Is that the question? And the answer is, I guess sometimes they are. As part of the build, though, the build will pull in the pieces that are required to produce the tools that the team needs. Right. So the Eclipse team in particular is pretty good at assembling the bits that they need. They actually don't include in their distribution directly. They don't actually include the Git support, though. So the developers will pull down the latest bits, install the latest version of eGit into the latest bits, and then use that to work. They use exactly the same workspace they were using yesterday or the week before, and just move forward from that. Other questions? Oh, yes.
What do you use for the build navigation and the packaging? Also done by Eclipse build?
So the question is, what do we use for build aggregation and for the packaging? We have the Buckminster project provides a build aggregator, and what this is, so try not to get too deep into some of the technology that we use, but Eclipse produce P2 repositories. P2 is our provisioning technology, runtime provisioning technology. The P2 repositories contain all the plugins that you wind up pulling into your Eclipse. The build aggregator that's created by the Buckminster project knows how to take a collection of P2 repositories and combine them together into a single Uber P2 repository. The packaging technology is actually similar. It uses the P2 provisioning technology to pull. You can provide a script to the packaging project, and it's actually a relatively small amount of custom code is used to connect to the repository and pull all the different pieces together, pull in the executables and all the DLLs and libraries and stuff that are required, and generate the package. So that's some custom technology that we have that's based on P2. Other questions? All right, well, good. Thank you. Enjoy the rest of the conference.